Hello guys, this is section 1.6. This is about solving linear inequalities. This should be mostly review, and then maybe by the end we'll get into some new material. An inequality is different than an equality, obviously. An equality would have an equal sign in it, and an inequality could have one of these four choices. It could have a less than sign, or a greater than sign, or a less than or equal to, or a greater than or equal to sign. You guys are going to be expected to simplify or solve these inequalities, um, as well as graph the inequalities. So to simplify an inequality or to and to graph it, what you need to know is that a less than or a greater than sign are going to have open circles. Let's do that in a different color. They're going to have open circles. Meanwhile, a less than or equal to sign or a greater than or equal to sign, like these ones, have the filled in circles. And the graphing that we're going to be doing is on a number line, not the type of graphing that would have like an X, Y. The two, that's for two variables. We're not going to be doing that yet. And I know that you guys know how to do it, but we'll act like you don't until we get to the material. So we've got these inequalities. I'm calling these simple inequalities because we have other types that we're going to learn that are compound inequalities in this section. But just for simple inequalities, we have something like X is less than 2, and I expect you guys to graph it. Basically, just put a number line down and put the main number in the middle, 2, and put one number smaller and one number bigger. And then I said less than 2, and I said up here that less than is going to have an open dot. So just go ahead and put an open dot somewhere. Some people like to put it on the line, but I don't like to because I like to be able to see if it's open or closed really easily. And then numbers less than 2 would be that direction. So just an arrow, and that's it right there. So here's another one. X is greater than or equal to now -1. So put -1 in the middle. A number bigger than -1 is 0. And a number smaller than -1 is -2. Greater than or equal to. Remember, if it's got an or equal to, it's a filled in circle. The filled in circle is to signify that we do want to include the value of -1 that does actually answer the question. And then numbers greater than -1, numbers bigger than -1, right, are that direction of -1. So anything at -1, including -1, or to the right of on the number line would satisfy that inequality, and therefore that would be our solution. Now we are also going to have, like I said, compound inequalities. Simple inequalities, it's one number. A compound inequality, there's actually going to be two different types of compound inequalities. We're going to have and variety of compound inequalities. A couple things about and inequalities. And inequalities are always, always, always written in this specific format. And that's going to be maybe something that we revisit a lot this year, and something that people get wrong a lot in this chapter 1 test. So, and inequalities are always written in this specific format, which is the variable has to go in the middle. The smaller number is on the left side and the bigger number is on the right side. So I'm trying to do a little number sign here and the big number sign there. And then the type of inequalities that it's always using are going to be less than signs. And it could be less than or equal to, could have that little symbol there, but it has to be less than signs. It cannot be a greater than sign or a greater than or equal to sign. If we think about what this question is asking, -1 is less than x is less than 2. What you are attempting to find, if we think about this from x's perspective, is we want to know the numbers that where x is less than 2, so x values, numbers smaller than 2. And also, if we read this from x's perspective rather than from -1's perspective, we would say x is greater than -1, right? Because this is a less than sign, but we would say -1 is less than x. We can also read it in reverse as x is greater than -1. So we want numbers, when we graph it, our solutions are going to be less than 2, but greater than -1. And that should give you some ideas of what numbers you should be able to think of, a few that would satisfy that, and we're going to graph those. With these compound inequalities, I'm not asking for a ton here. Put the smaller number on the left, the bigger number on the right, put a number in the middle of them. Really easy to think about the number 0 here. It would be right there. The 1 would be over here, but that's enough information for me. And then go to each one of these individually. X is less than 2, that would be an open circle, and then less than would be that direction. X is greater than -1, once again, an open circle in that direction. We don't even really like to leave the arrows there. What we like to do, we like to have it like one line. Boom. So the line is to indicate where the solutions exist, what X values would make this a true statement. And any number between -1 and 2 would work, but not including -1 or not including 2. So this is a compound and situation. We are also going to see compound or situations. And an or situation would say, hey, X can be greater than -1, or X can be less than -4. It can be either or. It doesn't have to be both for it to be solutions. So, and inequalities are always written smallest number less than X less than bigger number. And or inequalities are just two individual statements with the word or in the middle. When it comes to graphing these, once again, put the smaller number on the left. The smaller number here is actually -4. And the larger number here is -1. I want to think about one number in between them, and I'll just put -2 here. It doesn't have to be perfect, but just kind of a general idea. And then graph each of these individually. X value is greater than -1, well, greater than or equal to -1, that's actually going to be a filled in circle. And X value is greater than -1 would be that direction. Meanwhile, this one here would be an open circle, right? Because it doesn't have the or equal to sign. And X values less than -4 would be that direction. And so that would be us successfully graphing this question here. Let's go ahead and pause it here and then have you guys graph both of these situations, make sure that we are understanding that before we proceed. So like I said, go ahead and pause that and do these. All right, so X value is less than 1/2 or X value is greater than 2. The smaller number would be 1/2. And the larger number would be 2. I like to put a number in between them, so I'll put 1 right there. X value is less than 1/2, open circle, less than. X value is greater than 2, once again an open circle, and greater than would be larger, would be that way. Now here's our compound and statement. Remember, you put the smaller number on the left, bigger number on the right. Put something in between them. Let's go with 0 again. -3 is going to get an open circle. 1 is going to get a filled in circle. Then we can connect them, right? Because it's going to be X values less than 1. That'll be that direction with an arrow. X values greater than -3. That'll be that direction with an arrow. Meaning they just kind of connect. So or statements are always going to be graphed with arrows pointing away from each other. And statements are always going to be like dots, filled in or open, and with a line connecting them. So we are going to have situations where we are graphing inequalities, and it's not as simple as those previous examples, right? Where we don't already have X on one side by itself. We have to actually do that simplification or that solving. So here we have an example where we have multiple X's. It's not simplified. We can't graph it yet. So we need to go to that work. We need to actually simplify this first. And thankfully, in the previous sections, we've been simplifying statements like this. In fact, if this question just had an equal sign in the middle, right, if this was equal to, you guys should know how to graph that. Or sorry, not graph it. You should know how to solve it. You should be able to get the X's on the same side, the constants on the other side, and then go ahead and get X by itself. Once you have X by itself, then you could graph it. However, there is one change to this, and that one change is if you ever multiply or divide by a negative, And this is going to happen from time to time, certainly. Anytime you multiply or divide by a negative, flip direction of inequality. And I state this right here in longer words, but anytime you multiply or divide by a negative, flip the direction of the inequality. So let's go ahead and take a look at this example. There's a couple different ways that you guys would look to solve this, right? We're just trying to get the x's to one side and the constants to the other. Some people might subtract 7x here, and that's a totally fine thing to do. If you subtract 7x on this side of the inequality, much like an equation, you would also have to subtract 7x on that side. 7x minus 7x, those things cancel. Over here, we're going to get negative 4, greater than, just drops negative 4. 5x minus 7x is negative 2x plus 2. Now remember, we want the x on one side and everything else on the other side. So we have this multiply by negative 2 happening, and we also have a plus 2 happening. Well, we know from the previous couple lessons, the SADMAP order, you want to undo subtraction or addition first. So we want to undo this plus 2. We undo a plus 2 by subtracting 2. And if we subtract 2 on one side, we have to subtract 2 on the other. That's supposed to be a greater than sign. It's really ugly. Perfect. Negative 2x is greater than negative 6. Now x is being multiplied by this negative 2. I know that I need to get rid of that negative, that multiplied by negative 2, so I would divide by negative 2. Those are inverses of each other. And what I do to one side, I have to do on the other. Over here, they cancel, and we get x stays, and then we know that negative 6 divided by negative 2 is 3. So what I just said here is that anytime you multiply or divide both sides by a negative, you have to flip the direction of the inequality. So right here, we multiplied or divided by a negative, right? We divided both sides by negative 2. When we do that, we have to flip the direction of this inequality. It's a greater than sign now. I need to change that to a less than sign. That will be my simplified inequality. Okay, so just to reiterate, anytime you multiply or divide by a negative on both sides, like we did here, we divided both sides by negative 2, we have to flip the direction of the inequality. So we'd go up here to graph it, 3, number smaller, number bigger, x is less than 3, boom, we're done. I do want to point out that there was another approach that we could have done this question, and it actually just would have been a little bit smarter, but either way, you'd get the same answer. And actually not really even smarter, I shouldn't say that. It's just a different approach. If we recognize that we don't want to have negative x's, right? Like here, before we subtracted the 7x to this side, I could decide to move this 5x to this side instead. So I'd subtract 5x, subtract 5x. We'd have 2 is greater than 7x minus 5x is 2x minus 4. So then I would have to add this 4 over, get 6 is greater than 2x, divide by 2 on both sides, x is, or 3 is greater than x. Now, I don't really talk about this before, but when we have inequalities, we have to write x first. X is in the latter part. I'm never going to take off points if it was an equal sign and you said, hey, 3 is equal to x. I don't really care about that. This is the same either way. X is equal to 3 or 3 is equal to x. However, if you have an inequality, I would take off points if you don't have the x first. So what you end up having to do is just flip it, x. And if you read this from x's perspective, it would say x is less than 3. So that's what it needs to say. You're going to notice that we got the same answer over here. So I don't care which of these two ways you do it. You can bring the x's. I think it generally, it doesn't really matter, right? It's the same one. So let's look at some compound inequalities. With compound inequalities, whether it's an and or an or, we're still going to have very similar steps here. The and probably more so. So when you guys learned solving equations, you guys would often draw these vertical lines through the equal signs. I'm going to kind of do the same thing. We need to get x by itself here, and it's currently not by itself. So we have to solve it, much like we have been, and get the x by itself. X has a couple things happening to it. It's being multiplied by 6, as well as there's a subtract 10 happening. We need to undo both of those things, and we do have an order for that. SADMAP, we would undo the subtract 10. And so in order to undo a subtract 10, I would add 10. What's kind of unique about this is there are essentially 3 sides to our inequality. There's this one, there's the middle, and then there's the outside. So if I add 10 here, I have to add 10 everywhere. Those ones will cancel though. Over here we have a 6x. Those cancel, we just drop that 6x. 24 and 6. Very similar with this. X is now being multiplied by 6. I can't have that. I need to undo it. I can undo a multiply by 6x by dividing by 6x. And if I do it to one side, I have to do it to all the sides. 1 is less than x is less than 4. That is my simplified inequality. I, of course, I must make a mistake. Less than or equal to, less than or equal to, less than or equal to. Of course, when I graph this, I'm just going to graph it like we did before. Smallest number on the left, bigger number on the right. Put something in the middle of them. Number 2, I could do them all if I wanted to. X is less than or equal to 4. That's a filled in circle going that direction. X is greater than 1. If we read this from X's perspective, that's an open circle going this direction. I can just connect them with a single line, and I've graphed it. So here's another one. This is not a compound inequality. This is just a more simple inequality. We should be able to do this. We need to solve for x. X has a couple things going on with it. It's got this 15 with it, and it's being multiplied by this -3. We know that we undo subtraction and addition first, and oftentimes what people do is they take this negative and they apply it to the 15 somehow. But keep in mind, whatever sign is in front of a number is applying to that number. And this doesn't have a sign. We know that means it's positive. So in order to undo a positive 15, we're going to subtract 15 and -15 cancel. You have -3x is greater than 12. Now x is being multiplied by -3. In order to undo a multiply by -3, we need to divide by -3. And what we do to one side, we do to the other. Now, hopefully you didn't forget, whenever you multiply or divide both sides by a negative, which we did here, we divided both sides by -3, we have to flip the direction of that inequality. So we get x is less than 4, 4, 3, 5, less than 4, boom. Like I said, this you should be able to fly through. I'm not looking for anything fancy there. Let's then look at an OR example. With OR examples, it's going to be just like this one, except there's going to be the word OR in the middle, and there's going to be another one. So it's like you're doing 2. So basically break them up, do this one individually, do this one individually, keep the word OR in the middle. Make sure when you rewrite it, you still have the word OR there, and then graph it. 3x plus 5 is less than or equal to 11. I need to undo that plus 5. I can do that by subtracting both sides by 5. 3x is less than or equal to 6. So x is less than or equal to 2, or. Over here, same idea. We have a -7. We need to undo that -7, so we're going to add 7. Add 7. 5x is greater than or equal to 30, so x is greater than or equal to 6. That's my statement. 2, 6, 4. X is less than or equal to 2. That's a filled-in circle going that direction. X is greater than or equal to 6. That's also a filled-in circle going that direction. Notice that my x's were both first. I didn't have like 6 is less than or equal to x. If I wrote that as my final answer, I would be wrong. I would be a Boolean take off some things there. Our last one that we're going to cover is this compound and inequality. I would go ahead and try it, see how you do. Make sure that you're able to get the right answer. Remember, with these compound and inequalities, you're going to kind of subdivide them into three different sections. The first thing that you would look to undo is the subtract 5. You would add 5 to all sides. But then x is not by itself right now, and it's important that you guys know how to undo this. I think you do. Keep in mind that you could write like a -1 there. So x is being multiplied by -1. The way to undo multiply by -1 is to divide by -1. So what we get is 3. Now remember, anytime you multiply or divide by a negative on both sides, or in this case all sides, that direction of the inequality has to flip. And I guarantee I'm going to see this answer as the correct, in quotes, answer on multiple quizzes and tests. However, this is the wrong answer because it violates something that I talked about right away when we talked about compound inequalities. And that is that I said that and inequalities have to be written in a certain way. They have to be written as smaller number, less than, x, less than, big number. Now, this is pretty much all wrong, right? It's the bigger number is greater than x is greater than the smaller number. So it's pretty easy to fix, but you just have to recognize that it is incorrect. The smaller number needs to be on the left. The bigger number needs to be on the right. And then this isn't, we're not changing this. It says x is greater than -11. If I read this from x's perspective, it needs to say x is greater than -11. And it still does. Now it's a less than sign, which I needed. Same thing here. If I'm reading this from x's perspective, not the normal way, right? From x's perspective, it would say x is less than 3. Now it says x is less than 3, and now it's in the correct form for an and compound inequality. I can go ahead and quickly graph this. Here's -11. Here's 3. 0 would be somewhere over here. X values less than 3 would go that way, and x values greater than -11 would go that way. It's an and inequality. If we do everything right, it should just be the pointing towards each other, and then we've graphed it. So this is section 1.6. We are almost done with chapter 1. Let me know if and when you have questions.